In this example, you're asked to solve the equation 2 cosine of 2 theta minus the square root of 3 equals 0, where theta is between 0 and 360 degrees. All right, so the first thing that you should do is get the trig function by itself. So the first thing I would do is try to isolate the cosine of 2 theta. In the first part of the problem, don't worry at all about what's inside of the trig function, so the 2 theta here, or in another problem you might see like x over 2 or 3x. Don't worry at all about the argument. That's the word for what's inside. Just focus on getting the trig function by itself, cosine of whatever. And we'll worry later on about dealing with the inside. But so the first thing that I would suggest that you do is add that square root of 3 to both sides. I'm going to just squeeze over here. Oops, square root of 3. Okay, which gives us this equation. So 2 cosine of 2 theta equals positive square root of 3, and then divide both sides by 2. We'll cancel that 2 in front so that you've isolated the cosine function. So this is cosine of, the parentheses there are not essential, but I just like to write them in this case for clarity. Okay, so cosine of 2 theta equals square root of 3. Once you get the trig function by itself, then you're going to want to grab your unit circle. And I didn't paste a unit circle into my setup here this time, so I'm just going to draw. Cosine is positive in quadrant 1 and in quadrant 4, because cosine, remember, is given by the x coordinate on the unit circle. And so x is positive over here to the right of the y-axis. Okay, so I'm just going to draw in those points. Okay, so you get the coordinates square root of 3 over 2, positive 1/2. Let's see, we're working in degrees in this problem, so that's at 30 degrees. So 30 degrees is your quadrant 1 solution. And 330, it's the mirror image. It's 360 minus 30 down here. You're going to see the coordinates square root of 3 comma negative 1/2. But the 1/2, the negative 1/2, that's the value of sine. We don't care about that in this problem. But we've got the value of cosine that we want. Okay. Now here is where my explanation is going to differ a little bit from my math lab and from the written solutions that you see in the PowerPoint. So if you prefer those written solutions and you prefer that method, then that's fine. If you don't really, the method that you're seeing on the PowerPoint isn't really clicking, then this will give you an alternative. And ideally, understanding both gives you the fullest understanding of the material, if you can get comfortable with both, but that's not important that you do that. Or yeah, okay. So, all right, now we're going to worry about what's inside. So I know that I want cosine of either 30 degrees or 330 degrees in place of that 2 theta. So now I know, okay, my solutions are going to come from 2 theta equals 30 degrees or 2 theta equals 330 degrees. Okay, but here's the catch. You have to be careful when you've got more than just theta inside of your trig function. So, I mean, if it was just cosine of theta equals square root of 3 over 2, we'd be done. Theta equals 30, theta equals 330, there's my solution set. When you have more than just plain old theta in there, then you need to take the precaution of first describing all solutions. So remember, you can describe all solutions by just adding on that 360 in, which means we can add any multiple of 360, and that's just going to correspond to a full rotation, so we'll be back at that position where cosine has the value of square root of 3 over 2. Okay, so I'm going to add that to both of these. And make sure that you add this 360 in before you isolate theta. So as soon as, just going through the steps here, because I know these are tricky problems, you have to be real careful. First, isolate the trig function. Don't worry about what's inside. So trig function equals a value. Then you grab your unit circle. Find the angles that correspond to whatever value you're looking for. So we found these angles because they correspond to the square root of 3 over 2 for cosine. Then set what's inside, so copy what's inside the trig function down exactly, set that equal to those angles you got from the unit circle. And if it's more than just theta inside, make sure that you describe all solutions. So add 360n. Now we can solve for theta. And I guess I'm going to squeeze it onto this page. So to solve for theta, I need to divide by 2. So I'm going to do that across the board here. Same thing down here. Divide everything by 2. Make sure that you divide everything by 2, including this 360n. And that's where it's important that you put on that 360n before you isolate theta. So as soon as you, whatever the angle is, as soon as you set it equal to the angles you got from the unit circle, that's when it's time to add the 360. Okay, I know I've gone on and on about that a bit. So let me get a clean page and try to memorize what I need to. When I switch the pages back and forth with this program, it tends to mess things up. Okay, so with that first equation, it was 2 theta equals 30 plus 360n. So when we divide everything by 2, it's going to be theta equals 15 degrees plus half of 360, so that's 180n. Okay, or actually, let me write that over here. Or theta equals, so it was 330, we divided by 2, so now it's 115, plus it was 360n, so now it's 180n. Now remember that we're looking for solutions where theta is between 0 and 360 degrees. All of the solutions in that set. So I'm going to set up a little solution set here. If n equals 0, so if we don't add any, 180, if n, that's supposed to be n equals 0, then theta is 15 degrees. And that's certainly in the interval down here that we're looking for. So I'll go ahead and list that solution. Same thing over here. If n equals 0, then that's 115 plus 0. That's between 0 and 360 degrees, so we want to include that solution. Now what if n equals 1? Let's see if we're still in the interval that we were asked for. So if n equals 1, then theta is, equals, that should say equals, 15 degrees plus 180 degrees, so 195 degrees. And that is still, that does not look like 195, sorry. That's still between 0 and 360 degrees, so that's still in the solution set. What if I go over here, n equals 1? Then theta is 115 plus 180. I'm going to write it vertically like we do in grade school, so this adds up to 295, right? And that is still between 0 and 180 degrees. Okay, but we're getting close to 360, or closer. Notice if I let n equal 2, then this will be 360. 180 times 2, that's 360. Plus 15, that's going to be more than, I guess I should go ahead and write it out. If n equals 2, then theta is 15 degrees plus 2 times 180, which is going to give us 360 plus 15, that's 375. That's too big. That's beyond this value. And same thing here. If n equals 2, then this is 360 plus 115 more. That's going to be too big, more than 360. So you stop when you start to get values bigger than 360, and this right here is your solution set.